Dear students, in this video, we will see how we can evaluate our decision tree by using the criteria overfitting. Means overfitting is one of the evaluation parameter for decision tree. Now, what do you mean by overfitting? What do you mean by underfitting? And what are the techniques to overcome it? That all we are going to see in this video. Now, when we are training our model, then there are two types of the data. One is a training data, second one is a testing data. Training data is known as a seen data, while the testing data is known as a unseen data. If model is giving more accuracy for training data, but poor accuracy for testing data, then such model is said to be overfitted model. Means what? The model is not at all performing well for unseen data. The model is not at all giving me proper output for testing data. Then such model is called as a overfitted model. And I will not say such model as a generalized model. Model which works well for both training data and testing data is only said as a generalized model. So why overfitting has occurred? Because your data set is not clean. Why? Because it is containing impurities. Impurities means what? The data is most uncertain data. Randomness is existing in the data. It is containing unwanted, not related data. That is the noisy data. It is containing outliers. Outliers means what? I will give one example for it. Suppose I'm having one of the feature as age of a person. Age will be never be negative. Okay. But suppose one of the training sample is containing age as a negative, then it will be considered as a outlier. Missing data. Some of the values are missing. Imbalanced data means for all the classes, you are not having the same number of the samples. Such data is called as a imbalanced data. So these are the imperatives that are existing in your data set, and because of which your model is not giving proper accuracy for unseen data. In testing phase, your model is not performing well. It is performing well in training phase. Okay. Now, what do you mean by noise? That is a meaningless, irrelevant data. What do you mean by bias? Bias is a difference between predicted value and actual value. Now, what do you mean by variance? You can call variance as bias during testing phase. Means what? During training, the model is performing very well. But during testing, there is a huge difference between the predicted value and actual value. Then it is called as a variance. So variance exists during testing phase. Okay. Now generalization means what? Your model works perfectly for both training data as well as the testing data. Then that is called as a generalized model. Now, here you can see that if model is having error during both the phases, that is a training phase as well as testing phase, then that model is called as a underfit model. If model is having low training error, means it works perfectly during training phase, but it fails during testing phase, then such model is called as a overfitted model, that is giving me high variance. But the model which is working well, which is giving me low error for both the training phase and testing phase, then that model is optimum model, or you can call it as a generalized model. So these are the examples. Means this line is not at all dividing my cross and circles. Now this line is trying its best. Now this line is taking so many curvatures and trying to fit hardly between the cross and circles. Now, why overfitting is occurring? Because of the existence of the noise and inaccurate data in our data set. And the overfitted model is said to have a low bias and high variance as it is not performing well during testing phase. So, now, let us understand what do you mean by overfitting with one example. Suppose there are three students named X, Y, and Z. Now, student X has studied only the part of the book. Means he has not completed the syllabus of 5 units. He has completed only 3 units from the book, and he has not even touched the remaining units of the book. Now, Y has a good memory and he has memorized the whole book, only the book. Okay. But the third student has said he has practiced all the questions, means he has studied all the concepts in the book as well as the question bank given by the faculty as well as the questions those have appeared in the previous question papers. Means all the questions are prepared by Z. Now, if questions are from the first 3 units, then X can perform very well. And if the questions are from all 5 units, then X will be able to solve only the questions which are present in the first 3 units. Then Y will be able to solve only the questions if they are asked from book. If any application oriented question has asked which is not stated in the book, Y will not solve it. Means Y is not capable of solving unseen questions. But Z, as he has covered all the questions, there is nothing called as a seen and unseen differentiation for Z. He will work well, he will perform well for all the questions given in the exam. Now, you will easily understood what do you mean by X. X is a model which is underfitted. Z is the optimistic model, that is the generalized model. And Y is the overfitted model. That is what stated here. X is what underfitted, Y is what overfitting, and Z is the generalized model. Now, how we can find out overfitting? Means actually, if we are having a data set and we are only training our model with the available data set and we are not making it ready for the testing part, then your model will never work well for the unseen data. That's why your first responsibility is always divide your data into training and testing part. Okay. Generally, 70-30 or 80-20 splitting is there. Means 80% you give for training data and 20% you give for testing data. Means see the accuracy that you are getting for the training data and see the accuracy that you are getting over the testing data. If both accuracies are satisfactory, then your model is a generalized model. Now, one more solution is validation one that we will see, but these are some techniques which will reduce your overfitting. The first one is what? Increase training data. Yeah, your model should be perfectly trained again and again. Reduce model complexity. Perform early stopping, means give some of the validation data. And if it is a neural network, then we can use dropout, means some of the neurons will not be active in the next layer to handle overfitting. Now, how we can do the early stopping means what? How we can stop the training at early phase is how was our split of the training and testing? We have decided that the 80% of our data will be the training data and the 20% of our data will be the testing data. But out of this 80% training data, what I am doing again is 60% only I am giving for the training and remaining 20% I am putting for the validation. Now, I will give you a very simple example to understand this one. Suppose we are training you students, okay, by conducting the classes. But directly, we are not telling you to write down the OU exam. In between, we are conducting the assignment test or CI test or lab exams, etc. Okay, so that you can consider as a small scale testing that is called as a validation. So if you use this validation phase, then you can see how your model is performing on some of the unseen data. Then you can conclude how your model is performing on completely unseen data. So this is one of the solution for your overfitting. Now, what we are doing here generally in neural network is there are epochs. So you can check the validation accuracy at the end of each epoch, means at the end of each iteration. And testing is at the end of your training phase, means all the epochs are run, then the testing will come. So this is all about overfitting, which is used as one of the evaluation parameter for your performance of the model. Okay, thank you.